Now that we've done a couple examples of related rates problems, I've got the steps that I usually follow written down on the board here. So the first thing I do is I try to write an equation that gives me the relationship between the things that are changing, remembering that things that are changing are functions of time. And I've just got a couple of notes here. First of all, pictures very often help, so I'll often try to sketch the picture of the description that I have of the problem. And then this issue hasn't come up yet because it's just automatically worked out that way. But one thing to be aware of is that you should know all but one of the derivatives. So if you've got a situation where you have three functions of time, you want to know two of their rates of change or two of their derivatives, because eventually you're going to plug in everything that you know, and there should be just one thing left that you don't know. So if I had five functions of time, that would be fine as long as I knew four of their derivatives. Okay, once we've done that, we then take the derivative with respect to time of both sides, and then we can plug in the known values. And I've just got a note here to be very careful with the signs of your derivatives, because a verbal description of things is almost always going to give you a positive number describing the rate of change. But it might attach that positive number to the word decreasing or getting smaller or something like that. That's the verbal way that we indicate that something is decreasing. The math way that we indicate that is with a negative sign. So just because there's a positive number in the paragraph describing the problem does not mean that the derivative is positive. You've got to look and see whether the quantity in question is increasing or decreasing. All right, then you solve for the remaining derivative. Okay. And then I'm always going to ask you to answer the question in words. So this is your math answer, but this is your final answer. You're going to answer the question in words, and that's going to mean that the answer that you give here will be the absolute value of the derivative. Now, I'll be checking your work. So if a quantity is increasing, when you solve for that derivative, you should get a negative number here. But when you translate that into a verbal description of what's going on, you're going to take the absolute value of that and just use appropriate words. It's going down at a rate of this, or it's decreasing at this rate, or they're getting closer at this rate. So you'll use words to indicate the direction of things. Okay. And then you also want to include the units. The units will always be a fraction. The units on top are whatever the units are for the quantity that's changing. So if it was a distance, that's going to be something like meters or feet or miles or something like that. If it was an area, that would be meters squared or miles squared or whatever units you had, square units. Okay. And then the bottom will always be the units for time.